Hi everyone. Today we are going to take system of linear equation. So that is what I'm going to cover today. System of linear equation. All right. I'm writing equation in short here. So what we have taken before how to equation of a line or linear equations. So linear equation here is, for example, here if I have just x plus 2y equals 3. Is this one linear equation? Yes. Why? Because you have equal sign. And what is your variable here, guys? X and y. Your variable here, x and y, the highest power for x is 1. The highest power for y is 1. So we call it linear equation in two variables. So here you have linear equation in two variables. So I could write here just linear equation in two variables. What is my variable here, or what is my unknowns? X and y. So that is linear equation. So if I give another equation here, for example here, 3x plus y plus 2z minus w equal any number here, say equal 7 here. And this one equation, yes, because you have equal sign. Is this one linear equations? Yes. Let us check how many unknown you have here, or how many variable you have. You have 4, x, y, z, w. What is the highest power here, guys, for each one? Just 1. X to the power 1, y here, the highest power 1, 1, 1. All of them must be 1. So that is, we call it linear equation in 4 variables. Linear equation, how many variables you have? 4 variables. If it turn out one of them here is not 1, is 2, one of the variable is not 1, the highest power here is not 1, is 2 or 3 or any number, then we call it non-linear equation. We call it non-linear equation. So linear equation must, all your unknown or your variable, the highest power must be 1. That is, we call it system of, we call it linear equation. So now let me define here, I give you example, what is system here, guys? System of linear equation. What is system of linear equation? All right? So what is system of linear equation? I give you example here. For example here, if you have 2x minus y equal 5, and the second one here, x plus y equal 3. So that is equation 1, that is equation 2. When I look to equation 1, is that linear equation? Yes, because it's equation, equal sign, and the highest power 1, 1. So that is linear equation. The second one also linear equation, 1, 1. So that is because you have more than one equation, we call it system of linear equation. System of linear equation. And so how many equations you have here, guys? You have 2 equations. I have 2 equations, and I have 2 unknowns. 2 unknowns or 2 variables here. We'll call it unknown or variable. So that is system consists of 2 equations and 2 unknowns. All right, our goal for today here, how to solve this system of linear equation. How to solve this system of linear equation. So what do you mean solve? When I say solve, I'm looking for the value x and y such that those value x and y satisfy equation 1 and 2. If I put x here and y here, I must get 5. If I put it here, x here and y the same, x and the same y, must get 3. So I'm looking for the value x and y such that these values satisfy the all equation 1 and 2. Cannot satisfy one of them, then is not a solution. If satisfy 1 but does not satisfy 2, then is not a solution for the system of our linear equation. All right, so that is example number 1 here for system of linear equation, 2 equation, 2 unknowns. So let me give you another example here for system of linear equation. If you have x minus y plus z equals 0, and the second one here, 3x plus y minus z equal 1. The third one, y plus z equal 2. So that is equation 1, equation 2, equation 3. So is this system a system of linear equation? You have to check each equation must be linear. So here, how many unknown you have here, or how many variable you have? You have 3 unknown or 3 variable. You have 3 unknown or 3 variables. So what you have here then, if I look to this variable, the highest power 1, 1, 1. Here 1, 1, 1. And also the highest power here 1, 1. So what is x? The coefficient of x here is 0. That's the reason you don't have x. So so each one here linear equation. So you have a system of linear equation. How many unknown, guys, here? You have 3 unknowns. 3 unknowns or 3 variables. And how many you have equations? 3 equations. I have 3 equations. That is also system of linear equation. If it turn out one of these equation is not 1, say 2, one of these unknown is not 1, the power here, the highest power is not 1, is 2 or something, then the system, the whole system become nonlinear system, all right? And the way that we solve nonlinear system is quite different from the system of linear equation, depending on the technique that we are going to use. So that is, we call this system here, guys, because you have two equations, two unknowns, we call it 2 by 2. 2 by 2. This one here, we read it by 2, 2 by 2. And here you have 3 by 3, 3 by 3, 3 by 3. So in general here, maybe I should write here, a system is m by n, where your m here is, that is the number of equation, that is the number of equation, n here, that is your unknowns, your variable here, or your unknowns. So here is not always the number of equation equal to the number of unknowns. You may have, they are different. The number of equation does not equal to the number of unknowns. Well, I'm going to show you also, we are going to solve this kind of system. If you have number of equation equal to number of unknown, or if your number of equation does not equal number of unknowns. So what is my first technique here today I'm going to give you? It's called, I am going to solve a system equation here by graph. It's called graphical solution. What is graphical solution here by graph? How to solve a system of linear equation by graph? Of course, here it will be 2 by 2. We are going to consider here, you have two equations and two unknowns, and that is the one we are going to consider. It's called by graph. Let me give you example number 1 here. Example number 1, how to solve a system of linear equation by graph. So you have 3x minus 2y equal 4. That's the first equation. The second equation, 2x plus y equal 5. All right, so that is equation, I call it 1 and 2. Is this one linear? Yes, you have to check every time also, because unless I tell you solve the linear system, the following linear system, then I give you already, I'm telling you it's a linear system. But if not, you have to check. Here the highest 1, 1, 1, the highest power 1, 1, here 1, 1. So that is a system of linear equation. How to do that by graph? I have to graph number 1. What is a graph number 1 here, guys? Graph 1 here, I have its equation of a line, Recall here, guys, before I graph 1 here, I want you to recall here, equation of a line here, recall here, I give you that. If you have equation of a line, should be in this form, mx plus little b, or you have another form for a line, which is ax plus by. So you have here, I should write c here, that's a constant, ax plus by equal constant c. So you have ax plus by equals c. Because remember this one here, I can rewrite it like this, as I'm going to show you here. So you can solve this one for y. If you solve this one for y, I'm able to write it like this. But anyway, equation of a line should be in this form. Either this one is standard form, or should be mx plus little b. So now that is equation of a line, because look what you have, ax plus by plus 4. So your 4, that's your constant, your minus b here, your b minus 2, and your a3, right? So how to graph? I'm going to do that one by one. I go graph first equation of the 1, and then I graph 2 on the same x and the same y, and see what I'm going to get out of this, all right? I try to see what I'm going to get out of this. So now let us graph equation 1, guys. Graph 1. How to give graph 1? X-intercept. I have to go ahead and first find x-intercept from 1. How to get x-intercept? Where is the graph cross x-axis? Where is the graph cross x-axis when y equal 0? I put y equal 0 in equation 1. I put y equals 0 in equation 1, and then I see what I'm going to get. If I put y equals 0 in equation 1, here is your equation 1, just replace y by 0. So what you have 3x equal 4. I replace y by 0 here, so you get 3x equal 4. So what is your x? Your x equal 4 over 3, 4 over 3. So what did you get for the point? Your x 4 over 3 and your y equals 0. I put it in box like this. So that is our x-intercept. Now I need to get y-intercept. How to get y-intercept? Y-intercept, again, the graph cross y-axis. When the graph cross y-axis, when you have x equals 0. If I have x equals 0 in equation 1, because that is the one I need to graph, so what you have, equation 1 here, just replace x by 0 here. Then what you have minus 2y equal 4. Minus 2y equal 4. So I need to solve that for y. So what is your y? 4 divided by minus 2. You divide by the coefficient here, which is minus 2. If I solve that, you get minus 2. So what is the point here, guys? Your x is 0 and your y minus 2. I put it in box like this. So that is your, I need to get x-intercept and y-intercept for graph number 1. I'm going to put them right now, but one by one. Let us graph number 2. How to graph number 2, guys? Graph number 2, I have to get again x-intercept. I have to get x-intercept. Where is the graph cross x-axis? That is number 2, equation 2. So I have to put y equals 0 in equation 2. Where is equation 2? Here, equation 2. Just replace x by 0, guys. Then what do you have? You have y equal just 5. So what is the point? Your x is, sorry, I have to put y equals 0 in order to get x. I have to put y equals 0 in equation 2. I have to put y equals 0 in equation 2 in order to get x. So what is your x? So for this, you have 2x equal 5. 2x equal 5. Just replace y by 0. So what do you have, guys? So you have x equal 5 over 2. 5 over 2, which is 2.5. 2.5. All right? 2.5. So what is the point here? Your x is 2.5. What is 2.5? And what is your y? 0. That is another point here. So last one here, I need to get y-intercept for graph 2. For graph 2, for the line, that is represent, each one here represent equation of a line. So I have to put x equals 0. The graph cross y-axis when you have x equal 0. So I have to put here, guys, x equal 0. Where? I put that in equation 2. Then what you have y equal 5. You have y equal. So if I replace x by 0, you get y equal 5. So that is a 0.05. That is the last one. So now I need to sketch the graph here, guys. I need to sketch the graph. Usually when you sketch the graph or using graphical solution here, I have to give you graphic sheet so that you can have right scales and you have unit here so that you can graph it, not like this. All right, but I'm just explaining here. So 2.5. So let us. That is your y-axis here, and then that is your x-axis. So how to locate this one here? So you have for graph number 1, you have your x-intercept 4 over 3. So I write here 4 over 3 here, like this. And what is your y-intercept for equation 1? Minus 2. So I have minus 2 here, maybe minus 2 here. So that is your x-axis, that is your y-axis. Then I connect them. Just you have ruler here, just connect them. So that is the graph. I have to make it exact here a little bit because I'm sketching the graph. Remember, I don't need to have exact perfect graph, but I give you a graphic sheet so that you will have. So that is your x-intercept, and that is my y-intercept for graph number 1. I write 1 here, I write 1 here, so that I will have, that is represent line number 1, equation number 1 or line number 1. I have to go for number 2, graph number 2. I have x-intercept 2.5, so 2.5 maybe here, 2.5. What is your y-intercept for number 2? 5. So 5 it's here, 5 here. So I have just to connect them here like this. I have to connect them, and then I write here 2, and here I write 2 here, right? So what is, I'm looking for the solution. What is the solution? As I said, when I ask you to solve this system of linear equation, I'm asking you to get the value x and y such that those two values satisfy equation 1 and 2, satisfy 1 and 2. So which one here, as you can see, those two lines here, they intersect at this one point, and that is the solution because this point is a common point on line 1 and line 2, which means this point, any point on the line satisfy equation 1 for number 1 here. Any point on the line number 2 satisfy equation 2. So the only point, this one intersection point, that is the point on the line 1 and 2, which means satisfy equation 1 and satisfy equation 2. How to get that? If I have graphic sheet, I'm going to figure out what is your x. When I figure out x here, you'll figure out x is 2. And then I have to make horizontal line to get your y. What is your y here? So you have your x, that is a solution. I need to get this point, x is 2. In the graphic sheet, I make a vertical line. I try to figure out the point, or I make horizontal line like this in order to get y. So it turned out your x here is 2, and your y equal here 1. Is that the solution? Yes, that is the intersection point between those two. As you can see, they only intersect at one point. That is unique point here, 1 point. And this solution, we call it unique solution. Why we call it unique solution? Because it's only 1 point. That is satisfy 1 and 2, or that's the point on the line 1 and line 2. But if you take a point on line 1 here, it will be satisfy equation 1, but does not satisfy equation 2. So that is not a solution for the system. Solution for the system means you take a point x and y, satisfy 1 and 2. So now that is your x and y by graph. What you should do, if you want, you can check is the solution is correct or incorrect. How we check? I take those two values, I put it here on the left, in the system here on the left hand side, I must get 4. I put it in the left hand side here, I must get 5, which means they are the solution. Check here, let us, if I replace x by 2, I replace y by 1, so what do you have? You have 3, 2, I replace x by 2, minus, so that is, I call it left hand side in equation 1. Left hand side in equation 1, I write equation 1 here up on the equal signs, so left hand side in the equation 1. I replace x by 2 and y by 1, so you have 2, 1. If I simplify that, you have 6 minus 2, which is 4. That is exactly the right hand side here, which is 4. If I go for equation 2, guys, equation 2, left hand side in equation 2 here, so what do you have? Replace x by 2, you get 2, and here 2, and plus y. What is y here? So your y is 1. So if I simplify this, that is equal just 5. 2 multiplied by 2, 4, plus 1, 5. So that is exactly the value here. So this solution here is correct. This solution here is correct. Okay, guys? So that is the first example here by graph. I have the system. I have to graph each one separate on the same x and the same y. I try to see if they intersect. If they intersect at one point like this, then that is you have unique solution. So now let me give you another example here where you have this, they are not really intersect. They are not really intersect. Okay, so let me give you another example here. And then I have 3 examples for this technique here. All right, so example number 2, if I have 2x, I need to solve by graph, xy equal 1. And here's the second one, 2x plus y equal minus 2. All right, so I need to, that the system of linear equation is very clear. The first one is line equation, linear, which is the highest power 1. The highest power here 1. So that is each one here is linear equation. So now I need to solve this one here. How to solve this one here? Just by normal, as I did here, I need to go ahead and find x-intercept. I have to go ahead and find y-intercept. All right, and so on. All right, so always let us do that. Let me call this equation number 3 here, equation number 4, just to give any number here. So 3 and 4. So now I need to graph equation number 3. How to graph line number 3. It's a line here. How to graph line number 3. All right. So here, if you want, I could rewrite this one here before I graph number 3 here. You can graph it like as I did for this example here, or you could have I could write y equal mx plus little b. How to write this equation 3 here as y equal mx plus 3. So I need to get y. So if you can, equation number 3, guys, if I solve for y, what did you get? Solve for y. So y equal just 1 minus 2x. 1 minus 2x. So that is equation equivalent to number 3. So I could, if you want, you can write 3 again because it's still the same. They are exactly the same. Or I just give another number here. But remember, 3 and 5, they are exactly the same here. So that is, I could solve it like this. So if I solve equation number 4 for y again, so I solve here for y, equation 3. So that is, I solve for y, equation 3. Or just write number 3 here. So I'm solving for in 3, just in equation number 3, solve for y. If I go solve for y for equation number 1, solve for y, equation number 4 here. How to solve that for y? Again, so what is your y? You just take 2x to the right, so you have minus 2 and minus 2x. Minus 2 and minus 2x. Okay, guys? So maybe I take here and just to give you time to write. So take this one here out. Now I'm going to sketch the graph here. So I call this equation, say number, just give it number 6 here. So you can, so now as you can see, the equation number 5, equation number 6, they are equivalent to number 3 and number 4. Number 6 equivalent exactly number 4 here, and number 5, it's exactly number 3. So why I'm writing this? Because I need to figure the slope. What is the slope here, guys? What is your slope here? The slope here is, what is the slope of number 5 here? What is the slope of equation number 3 here, which is number 5? The slope here, if I compare mx What is your m? I could write this one here, guys, as negative 2x plus 1. Can I arrange here? Minus 2x plus 1. This one here also I can minus 2x minus 2. And just to rearrange this, the same. So just try to compare what is your m. Here in our case, what is my m? Your m is minus 2. So m1, what is m1? The slope of line number 5. The slope of line number 5 is minus 2. What is m2? The slope of line number 6. The slope of line number 6, that is 1. Again, minus 2. What is going on here? It turned out the slope here. I figured out the slope, they are the same. And I want for you to recall, guys, here, recall, if you have two slopes, if you have two lines, their slope, they are the same, then, as from last lecture here, so if you have two lines, recall here, if you have two lines, I should write two lines, they have the same slope. So if you have two lines, have the same slope, have the same slope here, then they are parallel. They are parallel. What do you mean parallel here? Parallel means they never, so they are parallel. So which means they never intersect. If they never intersect, which means there is no solution. There is no solution. So up to here, up to this remark, that's one way to solve this problem. It turned out those two slopes here, they are exactly identical. They are the same, which means the lines are parallel here, which means they never intersect or they never met. Because of that, I don't have solution for this system. There is no solution. That's one way. That's one way to figure out. Another way here is just by normal graph. If you haven't noticed this, so that's one way. Another way, graph, just by graph as I did before. So graph number 3, for example. How to graph number 3? You can graph number 3 or number 5 because they are the same. Or graph 4 or number 6, they are the same. How to graph number 3, guys? Just go ahead and find x-intercept. How to get x-intercept? You put y equals 0 in number 3. When I get y equals 0 in number 3, what did you get? Let us do that here, number 3 here. If I replace y by 0, so what do you have? You have 2x equal 1. 2x, I replace y by 0 here, you get 2x equal 1. So if I solve that for x, divide by 2, you get 1 over 2. So what's the point? Your x 1 over 2 and your y here is 0. Your y here is 0. So now I need to go ahead and find y-intercept. How to get y-intercept? Just both x equals 0. Y-intercept means the graph cross y-axis when x equals 0. If I put that in equation number 3, then what do you have? You will have y equal 1. Y equal 1. So the point here is 0 and 1 like this. So that is going to graph equation number 3 on line number 3. Equation of the line of number 3. So now if I do the same for graph number 4, guys, graph number 4, line number 4, go ahead and replace x by, I need to get first, I have to get x-intercept, I have to find y-intercept, and then I have to graph both of them here on the same x and the same y, the same graph. So here, what is how to get x-intercept? I have to put x-intercept, where is the graph cross x-axis? The graph cross x-axis when y is 0. When y is 0. I put that in number 4, guys. What did you get? So in number 4, here is number 4. Just replace y by 0. Number 4 here. So you have 2x equal minus 2. Right? 2x equal minus 2. So what is your x, guys, here? What is your x? Your x here is minus 2 divided by 2. So you get minus 1. You get minus 1. So the point here, minus 1 and 0. Minus 1 and 0. Right? So that is your x-intercept. I need to go ahead and find y-intercept. I need to get y-intercept. How to get y-intercept? Your y-intercept, again, where is the graph cross y-axis when x equals 0? In number 4. Here is number 4, just to go ahead and replace x by 0. So what did you get? I got here, when x equals 0, get y equal minus 2. Y equal minus 2 is a point 0 minus 2. All right? So now I'm ready to sketch the graph in the same x and the same y. That is your x. Right? That is your x and that is my y. Now I need to sketch this graph here. So what I have here, maybe take another bin here. So you will have, look at the first one, guys. What is the first one? The first one, your x, graph number 3. What is your x? 1 over 2. So I put here 1 over 2 here. 1 over 2 here. And what is your y, guys? What is your y? Your y here is 1. So I have to put 1 here. So and then just to connect them here, guys. Just to connect them like this. And I want to write equation 1. equation number 3 here, that just I call the number here. Usually I put it in the end for two end of the line here. So here 3 and here 3. So that I will not confuse, especially you have more than one line. So that is 1 over 2, your x-intercept 1 over 2, and your y is 1. And this graph number 4, what is graph number 4? What is your x-intercept? Is minus 1. So your x minus 1 here, that is minus 1. What is your y-intercept? Minus 2. So minus 2, it's here, minus 2. Then I connect them like this. All right? So I write here equation number 4 and here number 4. So that is represent number 3. Just both x-intercept to y-intercept. And likewise for graph number 4, both x-intercept to y-intercept. So what's going on here? As you can see, those two lines, they are parallel here, which means they never met or they never intersect, which means there is no solution. Because I'm looking for the solution that on the two line, I'm looking for the solution, take a point, must be on the two line, but here they never intersect or they never met. Because if you take one for a previous example, when you have unique solution, they intersect or they met at one point and this point on the two line, so which means satisfy equation, the two equation. But here they never intersect, so which means there is no way to get value for x and y satisfy 3 and 4. So because of that, for this case, no solution. I don't have solution. No solution for this system. All right, guys? So that is no solution for this system. So now I have to give you another example here. And then I finish this part, which is by graph. And this here by graph, because we consider 2 by 2, just for simplicity, because it's easy to show in x and y in 2 dimension like this. Okay? So I give you here another example here, example number 3. And then take this one here out. That's one way here, as I said. That's another way. The first way, you know, by getting the slope of the two line, and you figure out they are the same, and because of that, they are the same. Because of that, you will have what's called here. You have here. You figure out the two slopes, they are the same. They are parallel, which means they never intersect or meet. You can tell me because of that, no solution. That's also acceptable here, and or by graph like this, and you figure out they are parallel. And then no solution. That is another way. All right, example number 3, guys, here. Example number 3, I would like to give you here by using another example here. So you have x minus y equal 1. And the second equation minus 2x plus 2y equal, maybe I write here. So x minus y equal 1. The second one here, minus 2x plus 2y equal minus 2. So just, you can, each example you can write 1, 2, or just to give a different number is okay. So that is 1, 2 here like this. All right? So now, how to sketch the graph of this one here. So now, let me graph by graph 1. How to graph 1 here, guys? Graph 1, I need to get very quick x-intercept. Where is the graph cross x-axis? When you have y equals 0. I put that y equals 0 in equation 1. So if I replace y equals 0 in equation 1, so what's your x? Just 1. Just 1. All right? Just x equal 1. So you have the point 1 and 0. I put it like this. All right? So now I need to get y-intercept. How to get y-intercept? In order to get y-intercept, I have, where is the graph cross y-axis when x equals 0? I put x equals 0 in equation 1. So if you have that, you get minus y. I replace x by 0, you get minus y equal 1. So what is your y? You just multiply both sides by minus 1, you get minus 1. Minus 1. So what is the point? 0 minus 1. So that is the point for graph number 1. I have to go ahead and graph number 2, guys. Graph number 2. Again, very quick. What is your x-intercept? In number 2, just replace x by 0. X-intercepts where the graph cross x-axis. When you have y, not x, you have y equals 0. I have to put in number 2, guys, y equals 0. So what do you get? You get minus 2x equal minus 2. Minus 2x equal minus 2. So what is your x? Your x here is just 1. Your x is 1. So what is the point? The point for this graph, x is 1 and your y is 0. And your y is 0. I put it in box like this. All right? So that is your x-intercept. I need to get y-intercept. How to get y-intercept? when x equals 0 because the graph cross y-axis when x equals 0. I put that in number 2, guys. Here, I replace x by 0. What did you get? You get 2y. If I replace x by 0, you get 2y equal minus 2. So what is your y? Minus 2 divided by 2, which is minus 1. So what do you have? You have 0. You have 0x, here 0, and minus 1. So now I can sketch the graph on the same x and the same y. In the same x and the same y. I try to see what I'm going to get out of this. All right, guys? So now, so here maybe I graph it here. So if I graph this one here, guys, so that is your y-axis, and that is my x-axis, okay? So now the first graph number 1, your x-intercept is 1. X-intercept is 1. So I have to write x at 1 here. And then what is your y? What is your y-intercept? Y-intercept is minus 1. Minus 1, so I put it here. So then I connect them like this. So I connect them like this. So it's a line. So that is intercept here. It should be minus 1 here. You know, I'm just doing, I don't have a ruler here. So it's 1 and minus 1. So I write here that is equation 1, or that is line number 1, right? 1 minus 1. So now I need to graph number 2. When I graph number 2, guys, maybe I take different color so that you can see the whole thing. So graph number 2 here, your x again intercept is still 1. So I put it in green here. You have 1. What is your y-intercept? Minus 1. Minus 1. So it's still the same. So I connect them here again. I connect it here. You will see the green here, the green, one green and one blue. So they are coincident. That is also number 2. So what that is graph line number 2. That's line number 2 and line number 1. So what's going on here? The two lines, they are coincide here, which means they are over each other like this. So how many points on the two lines? Because they are over each other here, like overlap, which means this, if you take any point, you will see any point on the line. How many points on this line? You have infinite. You have infinite point. So if you take any point, you will see satisfy 1 and 2, because the point here on the two line, 1 and 2, so which means satisfy 1 and 2. So for this example here, guys, we have infinite solution. We have infinite solution. So we have infinite solution because they are overlap or they coincide here, means that exactly the same. They turn out 1 and 2 the same. So that is one way here by graph. We figure out the two line, either the overlap or coincide, means you have infinite solution because how many points on the two line here? You will have infinite point, and each point satisfy the two equations, the two line 1 and 2, which means equation 1 and 2, which means solving it will be a solution for the system. So that is one way here. Some people they say, I have another way here. What is another way? Another way here is before you graph or you spend time to graph, I note something. I ask myself, is there any relation between equation 1 and 2? Is there any relation? I note something here. You have here 2, you have here 2, you have 2. So for equation 2, guys, just a remark here. I'm just writing as a remark. For equation number 2, if you divide by 2 here, guys, what did you get? You get divide equation 2 here, divide equation 2 by 2, just number 2. So what did you get? You get minus x, divide by 2, minus x, plus y equal, divide by 2, you get minus 1. So now that is equation 2, the same. I'm dividing each term by 2. So now I compare equation 2 with equation 1. Is there any relation? Yes, you have x, but here you have plus x, you have minus x. You have here plus y, here minus y. You have 1, you have minus 1. So what's going on here? If I multiply equation 2, the new 2 here by minus 1. If I multiply by minus 1, you get x. That is become minus y, that is you get 1. Best multiply each term by minus 1, you get this. So what did you get? Equation 2 exactly turned out identical with equation 1. Equation 1 and 2, they are exactly the same. So because of that, the graph should be exactly the same, which means how many solutions you will have, which means you have infinite solution. We have infinite solution because I note without graph or anything, after I simplify, I ask myself, is there any relation between the two equations? It turned out, if I divide by negative 2 here, you will get exactly the same, right? If you divide equation 2 by negative 2, you figure out exactly equation 1. So which means the two line or the system, two equations, they are identical, means we have infinite solution. We have infinite solution. All right, guys? So we have infinite solution. So that is very much how to solve a system of linear equation by graph. So now I have to give you another technique, which is how I'm going to solve a system of linear equation by elimination. All right, guys. So just you can write here so that I can take this one here out so that I can start from beginning here. So I take this one here out. It's okay to take it out. So I think I can take. So you can just give you 1 minute. Just you can write here as soon as I take it slowly here. But you can do that here also as take this one here out. You can practice. All right. So I take this one here out. So that is we have infinite solution because they are concise as you can see here. I take this one here out. So that is also my remark here. They are identical because they are identically have infinite solution. Okay, all right, guys. So okay, guys. So now I'm going to how to use elimination to solve a system of linear equation. That is called here elimination. How to use elimination technique or method to solve system of linear equation. All right. So let me the best here to give you by example here. So how to solve the question here? Example number 1. Just solve the following system of linear equation by elimination. X minus 2, y equal 3. That is equation 1. Equation number 2, 2x plus y equal minus 1. That is equation 2. Remember that I'm telling you solve the following system of linear equations. So I'm telling you the system here is linear equations. Or you can check the highest power for your two variables, your unknowns. The highest power should be 1. Or the highest power here should be 1 like this. So here 1, 1, 1, 1. So that is linear equation. So you have system of linear equation. So the idea here of elimination here is to get rid. How many unknown you have here? You have two unknowns and you have two equation. We have two equation and two unknowns or two variables, right? You have two unknowns. So the idea here is I'm going to get rid of either x or y so that I will get only one equation in one unknown. So I try to get rid either, it's up to you. You can get rid of x or get rid of y in order to get one equation in one unknown, and then you can go easy, because if you have one equation in one unknown, it becomes very easy to solve. So for example here, if I say 2x plus 1 equals 0, what is this equation? Is this equation one unknown? Yes. What is the unknown here? X. Your unknown here, x. If I have this equation, you have one equation and one unknown, it's very easy to solve because you can write here, take x, take negative 1, 1 to the other side become negative 1, divide by 2, you get minus 1 over 2. So here you have two equations and two unknowns. So what is the idea? To get rid of one of these unknown so that you can get one equation in one unknown, and then you are able to solve this equation. So now let us look what you have here. Here you have minus 2y. You have here, what is the number in front of x? X. And what is the number here in front of x? 2. So if you decide to get rid of x, then I have to multiply equation 1 by 2. If I multiply, or minus 2. If you want, I'm going to add. So here you have 2x, but here you have x. Let us decide, or let us get rid of x. How to get rid of x? I multiply. So I have to multiply equation 1, multiply 1 by minus 2. Just multiply by each term, multiply that by minus 2. So what did you get? X multiplied by minus 2, you get minus 2x. What you have here? Negative 2. Multiply by negative 2. Here you have negative 2. If I multiply that by negative 2, then what did you get? You will get plus 4. Plus 4. Negative 2 multiplied by negative 2, you get plus 4. Y. And here 3 multiplied by negative 2, you get negative 6. So this equation here exactly the same like 1. The equation is still the same, still the equal sign the same, everything exactly the same, because your equation here it's like balance. If you multiply by 2 here, by negative 2 here, you must multiply by negative 2. If you multiply both sides by negative 2, your balance is still the same or still valid, is still okay. So this equation is exactly the same. So there is rewriting here. If you want, I can equation write it 1 the same, or I could write it, give it different number. So equation 2 here, so I rewrite, I multiply both sides by negative 2 in order to get this. Then equation 2 exactly the same, should be the same. 2x plus y equal minus 1. So that is equation 2. Then I'm going to add, say, just equation 1 plus equation 2, guys. Equation 1 plus 2. So negative 2x cancel with 2x. That's the idea. I'm just multiply by negative 2 to get rid of x. So now I'm just adding negative 2x plus 2x, you get 0. Right? Plus 4y plus y, you get 5y. Here, negative 6 plus negative 6 here with negative 1, you get minus 7. Is that, you follow, guys? You get minus 7. So now, what is your y, guys? What is your y from here? Your y here, just go ahead and solve that for y. I divide by 5, you get minus 7 divided by 5. Minus 7 divided by 5. That is the value y. But here, when I ask you to solve, I'm asking you to get the value x and y. X and y. So when I get rid of x, you have here, I'm able to get y. I got one equation in one unknown. What is your unknown here? Your y. I'm able to, it's easy to solve that for y. I solve it, you get that. But I need to get x. How to get x? It's up to you. You can go back to equation 1, guys. I can go back to equation 1 or 2, one of them, or equation 1 or 2, and then I'm able to get x. So it's easy to go for use number 1. For equation number 1, if I replace, if I put y equal minus 7 over 5 in equation number 1, so what did you get? What did you get? So first I have to solve that for x. So you have x minus 2, and I replace y, just replace y, only y by minus 7 over 5. And that is equal 3. That is equal 3. So now I multiply by negative sign. So what did you get? You have x, negative times negative, you get positive. Positive, and here you have 14. 2 multiplied by 7, 14 over 5 equal 3. So now, what is your x? Your x, my x here is what? Your x is just take 3 minus, take 14 over 5 to the other side. So you have minus 14 over 5. So if I can write this as 15, because here you have 5, I could write that as 15 over 5. And here minus 14 over 5, because 15 over 5 you get 3. I combine them now, you get 15 minus 14, you get 1 over 5. So that is my x. So the solution here is, you have x equal 1 over 5, you have your y equal minus 7 over 5, and that is because you have only one value for x, you have one value for y, we call it, we have unique solution. We have unique solution because it's only one value for x and y. So I have unique solution. So your x, if you want, you can check if you are this two number, that is a number, is your solution correct or incorrect, is not correct. So you have to check. You go back to equation, as I said before, I can put that in my left hand side. In the first equation, I must get 3. I have to put that also here in order to get minus 1. All right. So here I want, I can maybe check this one. So if I put that in the left hand side, check. Just try to check. That is extra here, but you don't need to do that. But if you want, you can do it in order to make sure you are doing correct or incorrect. So your left-hand side in equation 1, left-hand side equation 1, what is your x? Your x here is 1 over 5, 1 over 5. So minus 2, what is your y? Your y here is minus 7 over 5, minus 7 over 5. Right? So that is your x, 1 over 5, I put it here. What is your y? Minus 7 over 5, I put it here. So I put between brackets a negative number. So if I simplify that, you have 1 over 5. Negative here was multiplied by negative, you get positive. 2 multiplied by 7, you get 14 over 5. So what did you get? 1 plus 14, you get 15 over 5, which is 3. What is 3 here? That is your right-hand side in equation 1. Right? You can check, of course, if you can check for the other equation here. You can check the left-hand side in equation 2. In equation 2 here, that's called left-hand side equation 2. So what do you have, guys? In equation 2, you have 2x. What is your x? 1 over 5. Multiplied by 1 over 5 plus y. What is your y? Minus 7 over 5. Minus 7 over 5. So you get 2 over 5 minus 7 over 5. If I combine this, you get minus 5 over 5, which is minus 1. Which is minus 1. All right? So that is exactly minus 1 here. So what I'm doing here is correct. What I'm doing here is correct. All right, so let me give you another example here. Let me give you another example here for this part here, and then we'll see how, we'll see this one here. So what is your x here, guys? My x here is 3x plus y equal 4, and minus negative 6 minus 2y equal 5. So that is equation 1, that is equation 2. What is the question? Solve the system by elimination. They ask you to use this elimination technique. They are very specific. Use elimination technique to solve this system. All right? How to do that? I have to get rid of either x or y. In previous example, we get rid of x. So let us get rid of y. How to get rid of y? I figure out here your y is 1. The number in front y is 1. What is the number in front y here? Is -2. Is -2. So what I'm going to do, I'm going to multiply equation 1, multiply 1 by 2, just by number 2 here, guys. All right? Multiply equation 1 by 2. So now, what you have here, guys, if I multiply equation 1 by 2, then you'll have, that is equation 1 here. So equation 1, and multiply both sides. So you have 3x plus y, and here also 2 multiplied by 4. So as you can see, that is my left-hand side. That is your left-hand side. Right-hand side here, 4, I put it here. So 2 multiply. So multiply each side by 2. Your balance, your equation exactly is the same. So if I simplify that, you get 6x. 2 multiplied by y, you get 2y. And here, 2 multiplied by 4, you get 8. Is this one equation 1? Yes, the same one. Or if you want, you can write different numbers, say call it number 3. But keep in mind, it's still exactly the same like number 1. Equation 2 now, I multiply by 2, equation 1 by 2, but equation number 2 exactly the same, should be -6 minus 2y equal 5. That is equation 2, right? So now, what happens if I add them? If I add here, guys, 1 plus 2, if I add them here, guys, what did you get? If I add this one here, 1 plus 2, look what you have, 6x, cancel with -6x. So what did you get? You get 0. 2y, cancel with minus 2y. So you get 0 again. So here, when I add 8 plus 5, you get 13. So what did you get? You get 0 equals 13. Does that make sense? No. So that is no sense, right? So because no sense here does not make sense, then there is no solution, which means those two lines, they never intersect, or they never. When you have 0 equal constant, means something incorrect. So what's going on here? In this example here, I don't have no solution. I don't have solution for this system because I end up with 0 equal constant, and that does not make sense. All right, I give you another example here where as a third example, and then we can give you another technique how to solve a system of linear equation. All right, guys, linear equation. So I give you another example here, example number 3 here. So what you have minus x plus 2y equal 1. All right, 3x minus 6 equal minus 3. All right, so what is the question here? The question, solve by elimination technique to solve the following system of linear equation. Here you have 2, so you have equation 1. Here you have equation 2, right? So now what you have, guys, here, I have to write y here. So you have -x plus 2y equal 1, and 3x minus 6y equal minus 3. So what I'm going to do here, guys, I have to using elimination here. So here it's up to us. You can let us get rid of x. All right, because I like when you have the unknown or your variable, you have the number in front that 1. It's easy to multiply by constant to get rid of this x. So now what happens if I multiply equation 1, multiply 1 by 3? That's number 3. So if you multiply each term in equation 1, multiply by 3. If you multiply minus 1 here by 3, you get minus 3x. 3 multiplied by minus x, you get minus 3x. 2y multiplied by 3, you get 6y. 1 multiplied by 3, you get 3. So that is exactly equation 1. That is exactly equation 1. So now I have to go equation 2 exactly the same. So I write equation 2 here, guys, minus 6y equal minus 3. Right? So now I'm going to add 1 here plus 2. Sometimes you have to subtract or plus or minus. It's what you really care, how to get rid of one of the variable. How to get rid of the one of the variables. Sometimes you add, sometimes you subtract here or minus. Either or is going to work. So now if I add, what happened? Minus 3x cancel with 3x. So I got 0. 6y cancel with minus 6y. So what did you get? You get 0. This one cancel with this. And here also equal sign 3 plus minus 3. What did you get? Is 0. So what is 0 equals 0? What does this mean? What does this mean here, guys? The two equations, 1 and 2, they are identical. Because in order to, when you get 0 equals 0, means The two equation is given equation 1 and 2, they are identical, which means I have exactly the same. If I graph them, by graph, as I show you, by graph they are coincides, like overlapping. So because of that, you have infinite solution. So if you get 0 equals 0, that makes sense here. So we have infinite solution, and that is telling you that two equation 1 and 2, they are exactly the same, they are exactly identical. How you show this one here? If I look to equation 2 here, in order to make sure what I'm doing here, what I'm saying correct, if I look to equation number 2, if I divide 2 here, if I divide 2 by minus 3, what did you get? Equation 2. So 3x you have 3x divided by minus 3, minus 6y divided by minus 3, and here minus 3 divided by minus 3. Each term divided by minus 3. Then if I simplify this, what do you get? You get negative x, and here you get negative 6 over negative 3, you get 2y, and here you get 1. As you can see here, what did I get after I divide by minus 3? Exactly equation 1. So which means those two equations, they are identical. In terms of graph, they are coincides or overlapping, which means you have infinite solution, as I explained to you here. But it's enough when you have 0 equals 0. Does that make sense? Yes, it makes sense. And because of that, I indicate here equation 1 and 2, they are identical. Because of that, you have infinite solution. All right, thank you guys. So next time here, I think I will give you how to solve by substitution. Okay, I will stop here. Thank you.